Today we are going to work on the distance formula. And the distance formula uses coordinates, just like the midpoint formula does. So you will need to make sure that you're labeling your coordinates again today. And the distance formula is d equals the square root, and this is a nice long square root sign, of x2 minus x1 squared plus y2 minus y1 squared. So again, that's the square root of x2 minus x1, it's in parentheses, squared, plus y2 minus y1, and that's in parentheses, squared. So you need two ordered pairs to complete the distance formula. Our first example, we want to find the length of AB and the length of CD. So both of these mean length because there is no segment bar over top. So the first one we need to find is the length of AB, and we need our coordinates for A and for B. So let's look over here on our graph, and A is on the y-axis. That means that x is 0, and we went up 1, 2, 3. So we're at 0, 3 for A. And then for B, we go to the right 5 and up 1. So we're at 5, 1 for B. And now we can use those coordinates in the distance formula, so we're just going to plug them in to the distance formula. So we have a nice long square root sign, x2, which is 5, minus x1, which is 0, squared, plus the y that went with 5, which is 1, minus the y that went with 0, which is 3, squared. Now, if you have an Inspire, you can type this all in at one time. I'm going to go through it real quick for those of you who don't have an Inspire or a graphing calculator right with you. So, first off, 5 minus 0 is 5, and we leave the squared with it, plus 1 minus negative 3 is a negative 2. Now notice that I'm putting that inside parentheses, because for those of you who do have a calculator, if you do this out like I just did and don't put the parentheses around it and type it in the calculator without the parentheses around it, you will end up with the wrong answer, because the parentheses tell the calculator that you need that negative sign with that 2. So next up, 5 squared is 25, plus negative 2 squared is a positive 4. We need to put that square root back, equals the square root of 29. And then we can go to our calculator, and if you just have a 4 function, type in 29, and then the square root sign, which means I need my scientific calculator up, so 29, and square root. We're rounding to the nearest hundredth, so notice that there's an 8 after the 3, so we're rounding up, so that's 5.4. Then we need to find the length of CD. So that means we need our points for C and for D. So C is going left 1 and then up 1, so that's a negative 1, 1. And then D is left 3 and down 4, so that's a -3, -4. Again, I do recommend labeling your X's and your Y's. So again, we're using that same formula for distance. So the square root of x2, which is -3, minus x1, which is a -1 squared, plus our y that went with -3, which is -4, minus our y that went with -1, which is 1 squared. Now for those of you using an Inspire, I'm going to go over how to type this in your calculator. So I need a calculator page, and then we need the square root sign. So the square root sign is the Control and X squared button, which is right next to 4. Open parentheses, negative sign, 3 minus a -1, close parentheses, squared. Now this is where some of you end up with issues, because you need to keep going and just press plus sign. Some of you, however, will end up pressing this over button, and that ends up outside of that square root, which means that everything's not getting square rooted. So you need to make sure that you are inside that square root sign, and that square root sign keeps going over the top of your equation. So plus, parentheses, -4 minus 1, close parentheses, squared. And if you need to rewatch how to do that, rewind the video. So we get 5.38516, and again we're rounding to the nearest tenth, so we have 5.4. So that means that segment AB is congruent to segment CD. If you have a problem like this on your assignment, you need to make sure that you're giving me the length of each of the segments, and then telling me whether or not these segments are congruent. And these segments are congruent because we ended up with the same measurement. Next up, continuing with distance formula, we're finding the length to the nearest tenth between K and L. Again, label your X's and Y's. So finding the length of KL. So if you haven't noticed, another word for distance is length. We take our square root of our X's. So -2 minus -7 squared, plus, and our difference of our y's, 0 minus -4 squared. And go ahead and type that in your calculator. And when you round to the nearest tenth, you should get 6.4. So for those of you who saw it in your calculator, you had 6.403. We'll look at the number after the tenths place and compare it. And that was a 0, so it stays put. Our next one, still finding the distance using the distance formula. So again, label your X's and your Y's. This time we're finding a length of FG. So take the square root of the difference of our x's, so negative 2 minus 9 squared plus 2 minus 5 squared. And again, go ahead and type it in your calculator. And make sure that square root, that bar over for the square root, keeps going over your whole problem. And you should get rounded to the nearest tenth, 11.4. Next up, we are looking at Pythagorean theorem. Pythagorean theorem works with right triangles. And your two legs form your right angle. So in this picture here, it's A and B are our legs. And the hypotenuse, your longest side, is the side across from your right angle. So it's really important to remember that the side across from your right angle is your hypotenuse. Pythagorean theorem, remember, a squared plus b squared equals c squared. And whenever you are finding the distance of 2 points on a coordinate plane, you can also use the Pythagorean theorem, because the Pythagorean theorem is derived from the distance formula. And you can also derive the distance formula, or the Pythagorean theorem, from the distance formula. So it goes both ways. So in order to use the distance, or the Pythagorean theorem, so a squared plus b squared equals c squared, we need our right triangle first. So what I recommend doing is, when you are on a graph like this and you already have your points graphed, take and make your right triangle. Now, to make your right triangle, you need to trace the grid lines. Now notice that I'm tracing all the way vertically and all the way horizontally across that grid line. I know that for some of you, that's more than you need to do, but for a number of you, you really need to trace that whole grid line. And the reason I say that is I've seen a number of right triangles that ended up going askew, meaning going off and not being right, which gets you numbers that aren't correct. So where those two grid lines meet up that you traced, put a point. That is where your right angle would be. Now count from one point to the point you put. So 1, 2, 3, 4. And double check. 1, 2, 3, 4. We're counting boxes, not lines. And again, 1, 2, 3, 4. Again, counting boxes, not lines. So 4 squared plus 4 squared equals c squared, our length, or our distance. 4 squared is 16 plus 16 equals c squared. Then we're going to add those two together. And 32 equals c squared. And then what's the opposite of squaring something? Taking the square root. So now we're going to take the square root of 32. And when you type it in your calculator, that's what you get. But we are rounding to the nearest tenth. And notice that this is the tenths place, so we need to look at the one behind it. One behind it is a 5, so we need to raise our score. So 5.7 is C. Our next one, we're just given points, and we need to find the distance between them. So we need to put our x and y axes on our graph. And then we need to graph our coordinates. So r is at positive 3, 2. So we're going right 3 and up 2. Label that r. And S is at negative 3, negative 1, so going left 3 and down 1, that is S. Now, just like I said to do with the last one, draw on your grid lines to make your right triangle between R and S. So from S to the point where those two lines intersect is 3 units. And from that point to R, 6 units. 3 squared plus 6 squared equals c squared. 3 squared is 9, plus 6 squared, which is 36, equals c squared. 9 plus 36 is 45, equals c squared. And then, again, take your square root. And when you type it into your calculator and get your square root, you get something like this. And again, we're rounding to the nearest tenth. So remember that that 7 is the 10th spot. We're looking behind it. That's a 0, so it stays the same. So we have 6.7 for our length for our S. Next up, the Forbidden City in Beijing, China is the world's largest palace complex, surrounded by a wall and a moat. The rectangular complex is 960 meters long and 750 meters wide. Find the distance to the nearest meter from one corner to the opposite corner. So I find that it helps to draw a picture for these. And we are going to draw a rectangle. And I know that looks a bit more square, but it's a rectangle. And it is 960 meters long and 750 meters wide. And we are going from one corner to the opposite corner. That means we are going along the diagonal. And we need to figure out what that length is to the nearest meter. So, what should we do? Use the Pythagorean theorem. So 960 squared plus 750 squared equals c squared, our length. Now I'm going to type all of this into the calculator at one time and get one really large number. So 960 squared plus 750 squared. We get 1,484,100 equals c squared. And then we're going to take the square root of both sides. And that gets us 1,218.236 meters. Now, we need to round to the nearest meter. So nearest meter means nearest whole number. So that means the ones place. So we need to look behind it, the 2. So we stay the same. So we have 1,218 meters is our distance across the complex.